Okay, running through. So problem number 1, since it has rained for the past 3 days in a row, the local weatherman assumes it will rain again today. This is an example of inductive or deductive. Inductive. You're looking for patterns, but there's not really a rule that goes with it. Okay. A lot of stuff in Vegas is done on inductive reasoning because a lot of times it doesn't matter. You're looking for a pattern, think you see a pattern. Guess what? There's not a pattern. The dice doesn't remember, and the blackjack cards don't remember. A and B, are you guys okay with those for number 2? Anybody stuck there? Number 3, provide a counterexample for each. Okay, remember? Yeah. I'll just do them all. All right, number 3, counterexample to A. 2 lines that never intersect are parallel. Okay, how I would answer A would be this. All right, let's put a line on the floor going here this way. Still with me? I'm going to put a line on the ceiling going this way. Will they intersect? No. Are they parallel? No. So there's your counterexample. So if you had, like 2 planes, and if you were to draw it, you could draw something like this, saying like this is a floor and a ceiling, and then you have a line going this way and a line going this way. If they were on floor and ceilings, those lines aren't going to intersect, but they're definitely not parallel. Yeah.
So if they're just on different planes, they won't intersect?
If they're on different planes, they won't intersect.
Like, is that what you meant by the floor and the ceiling?
Yeah, floor and the ceiling. So what I'm just trying to point out is they can be going 2 different, like if my arms are 2 different lines, they're not going to intersect each other because they're on 2 different planes. This is definitely not parallel to this arm, though.
Okay.
Does that make sense?
Yeah.
Okay. For any positive integers, a and b, a times b is greater than a. So a times b is greater than a plus b. Is that what it says? So any positive integers, so positive is? So if I did 1 times 4, that's greater than 1 plus 4. No, 4 is not greater than 5. So here's our counterexample right here. Okay? So 1 goofs things up. For the integers x and y, x plus y is greater than x minus y. So x plus y is greater than x minus y. And integers, if it's just integers, can they be positive, negatives? So if I had like -3 plus -5, is that greater than -3 plus 5 in this case? Because it would have been minus minus, right? So that's -8. That's greater than 2. And there's my counterexample right there. Okay? Yeah. Yeah. Remember, a whole number is starting at 0, going to infinity, counting by 1s each time. Integers are negative and positives, including 0. Let's see. Write the converse and the inverse and the contrapositive of each. Okay. So problem number 4. If I am under 18, I'm not going to write the whole thing, then I can't vote. Or I am not eligible. If I am under 18, then I'm not eligible to vote. Okay, I'm just trying to shorten it. Okay? So if I wanted the converse of this, which you guys have all pointed out, that's a pair of shoes, I'm just going to say if I am not eligible to vote, then I am under 18. Is that okay? So I just flip-flopped the hypothesis and the conclusion. Yeah?
Would you also have said if you are not eligible instead of I?
Yeah? So then the next one would be the inverse. And the inverse is putting the original statements, but I'm putting nots in there. So if I am not under 18, then I am not eligible to vote. What does not mean? So do I need that there?
Nope.
So I am eligible to vote. Okay? And then the contrapositive, it's the nots of our converse. So that could be if I am not eligible to vote, then I am not under 18. Do I need this not? No. If I am eligible to vote, then I am not under 18. Okay? I didn't ask if we were looking for true or false or any of those. Did it? Okay. Letter B. So your statement is if two lines are perpendicular, then they form a 90-degree angle. The converse of that is if two lines form a 90-degree angle, then the two lines are perpendicular, something like that. You might have to add a little bit more to make it linguistically make sense. The inverse is if two lines are not perpendicular, then they do not form a 90-degree angle. And then you contrapositive if two lines don't form a 90-degree angle, then the two lines are not perpendicular. Okay. We're on number 5, right? Okay, number 5. Determine whether the statement could make a good definition. If so, rewrite it as biconditional statement. Okay, remember biconditional means that everything is true. Okay, a right angle is an angle that is neither acute nor obtuse. Could I write that as biconditional? A right angle is an angle that is neither acute nor obtuse. Is there another angle that you know that is not acute or obtuse, but it's not a right angle? Straight angle, correct. So a straight line. So that's not going to work as a biconditional statement. Everything can't work as true. Two angles that add to 180 are supplementary angles. Can't really think. So let's go ahead and make that as biconditional. Two angles that add to 180 degrees are two angles that add to 180 if and only if they are supplementary angles. Something like that. Intersecting planes are planes that are not parallel. Intersecting planes, so roof and wall, not roof and floor. Intersecting planes are planes that are not parallel. Intersecting planes, if and only if. Intersecting planes are planes if and only if they are not parallel. So think about that. Parallel planes will not intersect. Planes in 3 space, they're either parallel or they cross. There's not a fourth plane that we're defining at this point. Decide each statement is true or false. Draw a picture for each. Through any 2 points, there is exactly 1 line. Put 2 dots on your paper. Draw a line through it. There's not a second line you can draw. When 2 planes intersect, they always intersect in a line. That is true. Okay, you're not going to get 2 planes that intersect. So you could have like the wall, and then you could have like a floor. And see how they intersect right here? Form that line. Okay, 2 planes will not intersect at a point. It will always be a line. A line and a plane always intersect. That's false, because I could have a plane. Let's say it's this along here, and then I could have a line that's right here going along parallel to it. It's not going to intersect it. It's in a different dimension. Okay. All right. 7, 8, 9. I think I just run through the whole proof. Okay. Ready? First thing I'm going to put is my given. Two points right there. 2 points for plagiarizing. Cool. After that, I might say something like this. Why? Distributive, right? 3, I might say this. Why? Addition. 4, I will say this. Okay, and then 5th step, because what technically just took place? What did I do to go from 15 over 2 to 7 over 7.5? It's division, right?
Could you leave it as an entropic factor, or do you have to
Well, they wanted you to prove that x equals 7.5, so
Oh.
I was just trying to get all the way to the answer. Okay, that's number 7. That would be 10-point proof. Yeah.
So is it okay when we did like 15 divided by 2 to just put it as x equals 7.5 instead of 15 over 2? Or should we
Oh, right. From if you skipped this step right here,
Yeah.
I think you'd be okay. I really do. Yeah. That'd be okay to skip. All right. Can I move off this board? Okay, number 8. Statements, reasons. Okay. First thing I'm going to put is angle A is right, given. 2. Angle B is right, given. Angle 3 angle B is congruent to angle C, given. Okay? There's 6 points right there. And some people will say, hey, can I put all the givens together? I guess you could. But the problem is each one of the givens serves a little bit different purpose towards this problem.
Okay, so you should put them separately, because like the answer is like.
I know, and I think they were trying to save space, and we as teachers were trying to be lazy. I think they should be all independent of each other. Yeah.
So, is it okay instead of right if I put 90 degrees?
Yeah. Let's see. Angle A. We're trying to prove that angle A is congruent to angle C. Is that correct? That's what we're trying to prove on this one. Angle A, angle B, angle A, or angle B is right angle B is congruent. Okay, cool. All right, so a few things that I would do. This is the step that is going to play gotcha. And again, we were trying, when we made the answer key in this, some of the teachers made it dirty math, okay? And why it's dirty math is congruent and equal theoretically do mean the same thing, but it has to be equal in order for you to substitute. Does that make sense? It has to have an equal sign in order to substitute, and a congruent sign and an equal sign are not the same sign. So I really feel an important step here is let's break this. Measure of B is equal to, I don't need the M. Angle B is equal to angle C. Why? Definition of what? Congruence. Okay? So this is a step. This is a step that don't shortcut it. Okay? Angle A is right angle B is right angle B is congruent to angle C, therefore angle B is equal to angle C because of definitions of congruence. So with us knowing that, other things we can do might be, and I know there's always going to be a little bit different from what I would show versus what the answer might show. What's right? They both are. Why? Because there's multiple ways to go through. So I want to have these defined for me in steps 5 and 6. What can I say? If angle A is a right angle, what can I say about angle A? Yeah. Angle A equals 90 degrees. I can also say that angle B is equal to 90 degrees. Why can I say that? Why can I say those? It's the exact same reason both times. Yeah. They're looking to be congruent, but I can't say that yet. Why can I say they're 90? Yeah.
Can you say that that's a definition of right angles?
Yes, I can. So, for step 5, definition of a right angle. Step 6, definition of right angle. Okay, now think about it. Let's go back and think about this for a second. Angle A is a right angle. I think right there, or it comes to your mind immediately going, right angle, 90 degrees. I'm there. You've been, led along far enough that right angles, 90 degrees go hand in hand. But now we're having to put it. Does that make sense? Okay, can I go down the screen a smidge? Okay, is it going to help me to say that 90 equals 90? No. All right, see who's paying attention to my notes from yesterday. Angle A is equal to angle B. Why? Not substitution, the other one. No. Transitive. Okay, substitution looks a lot like transitive. But if this is equal to this, and this is equal to this, it's a transitive property. You have 3 things. I have something equal to something else. Something equal to something else. That something else is equal to a 3rd thing. So 3 items are being tried to equal to each other. So this is known as the transitive property. Okay? Can I get away with trans? Yes. Or substitution. Because it's so new. It's so new. But we're eventually going to get to a point that we want to get away from the word substitution. Because substitution is really just, if I knew that x is equal to 2, and then I had some equation that I had x's in it, and I started putting the 2 in. Does that make sense? So being it's such a new thing for us to say, right now, I'm totally going to accept it, but I want to start branching away from it. Yeah?
So it's the difference between transitive and substitution is that there's going to be like blank equals blank above it, and there's going to be like 3.
You have 3 things that you're trying to prove equal. These 2 are equal, these 2 are equal, therefore the 1st and 3rd are equal. Does that make sense? But yes, as far as right now, the substitution is taking place, but a lot of times substitution will be, if I have x equals a number, and then you're working through a problem that has x in it, then you use the substitution property to put 2 in for x. Okay? It's not 3 different things that you're comparing. What's the last step? Angle A is congruent to angle C. Is it done? Is it done? No. What do I want? Yeah, you want to say this. But it looks like the same thing. It's so close. But you would hate to miss the 2 points. So, yes, we are here. We're not going to say this and this makes this congruent. I'm going to say that this and this, because of transitive property can't change an equal sign into congruent sign. Does that make sense? So we don't want to shortcut it, but I know that everyone's mind is going, but you know what I mean. That's where geometry is a little finicky sometimes. No, I don't know what you mean. Okay? So, this right here, I'm totally fine with definition of congruent at this point. Totally works. We've now proven it. Okay? Is this the shortest way I could have proven this? I don't know. honestly, when I go through one of your tests or quizzes, I'm going to try and do it as short amount of steps as possible. And however many steps, I double it, and that's how many points I would make the proof work. Okay? But let's say I'm grading yours, and all of a sudden it's like, oh, I did it in 10 steps, but they did it in 9. So then I have to go back through your thought process, which then becomes revenge on you guys against me, which is cool. Yeah.
Don't you need another step because you're trying to prove that A is congruent to C?
Oh, shoot. I sure do. Okay. We do. Thank you so much. All right, let's go a little bit. So we're trying to prove that angle A is congruent to angle C. Is that what we have? Okay. All right. Oh shoot. Okay. I think we can do this. I think we can. Yeah.
So above you said that for number 4 that angle B is equal to angle C.
I like it.
So then you could use the transitive property to like say that C is also equal to A because A is equal to B.
Ooh. Okay. Oh, I like where you're going. Okay. So because number 4 tells us this.
And then you go to number 7.
And then we go to number 7. So we know this and this. So we have B is equal to C. B is equal to A. That's totally the transitive property. Oh my gosh, you guys rock. Now, here's a quick question. Is this step here needed? I'd really be nitpicking it pretty hard if I took points away if you didn't have that step. And this is why. This is why, and it's going back on a little bit what I just said about the transitive property. We already had so many of the congruent scenarios taking place through this problem. Okay? Make sense? Coming down to here. So do I really need to, I already have, this is congruent to this, up there's congruent. Do I need to step back saying angle A is equal to angle C because of the transitive property, or can I make this move? Boy, I think that's a really nitpicky, I don't know if I want to go that far. If you did have it added, I think you'd be awesome. If you did this, you probably could say transitive here, and then if you said transitive here, that would lead that this step here is definition of congruent. Okay? I think you're fine. But again, this is when I'm going through your proof. I literally, when I grade a proof, it's not algebra any longer. I can't say, oh, look, oh, they have x equals 6, sweet. Or if the answer is 6 and you have 12, I'm going back through your work going, okay, where did they make a mistake? This is now, where is your mind thinking through this problem? And that's what I have to do with every proof. So you know how fast I was grading? It just slowed down a whole bunch. Sorry. I'll hopefully have it back in a day and a half versus a day. Okay? Questions? Well, I think we're going to just do algebraic. If we did throw one of these at you, it'd be really small. Probably like just a transitive property. Like A is congruent to B, B is congruent to C. Prove angle A equals angle C. Where you could, it would probably be something that simple. All right, can I move on? Let's see, what number is this one? 8? Can I go to number 9? Oh man, I love these. These are awesome. These are so much. And I know that you all think differently, and you're like, our teacher's nuts. Just go with it. Just, let me be nuts. Nope, not a reason. Statement. Reason. Okay. Number 9. We know that JK, segment JK is, what does this mean? Cool. And that's given. Then we want to prove, I'm going to draw this. I need to prove that JKO is complementary to angle OKM. I'm just going to draw a diagram just so I make sure I can do it. K M O. Okay, so that's what I'm trying to prove. Okay. So things that we know about perpendicular. What comes to mind with perpendicular? Two lines that intersect. What else comes to mind? 90 degrees when they intersect. I got you. Got it? It's a tougher ball, so I have to like give it a slug. Put it up there. Use your hand. Yeah, boy.
Oh, you didn't hear
All right. So JK is perpendicular to KM. 90 degrees should be sticking out. Okay, right angle. So things that I might state about this would be JK plus KM. No. We're not talking an angle. Oh shoot! Wait. Stop. Hey, look over there. Something's coming. So JK KM. I know it gives you the steps and the answers. I don't want to go there yet. So just by looking at this, so this is telling me we have this. Does it say that KO is an angle bisector? No. Do somebody want to jump right to that? Yes. Are you right thinking that? No. Okay, so let's think about this. Things that we could say that angle JKO plus angle OKM equals what? Okay, I'll go with that, JKM. What did we do? What? Yeah, that's it. Nice. Angle addition postulate. Cool? Does that make sense? Yeah.
Do we have to put angle addition or like just addition?
You can go with addition postulate. And it should be, because the postulate is like the big rule.
Okay.
So what rule are you really using? And being it's a postulate, that's like the law of the land. So you should refer to it. You can, I would say you could probably do things like this. You could say angle addition postulate, meaning angle add post, something like that. All right. That's pretty good. What are some other go-tos? Yeah.
I just have a question.
Uh-huh.
Kind of about this. How do you know where to go? How do you know what to do after you write down the answer?
The reason why I chose to go here is I looked at the diagram and I realized I was adding two angles together to get to a bigger angle. That's the only reason I went there right away. You know, wasn't because was there another step I could have went to? Probably. It's just I saw the diagram going, I know that I have this angle, and adding it together to get this bigger angle. And that's just because if I add two angles together, I get a bigger angle. That's really all. It might be I might put something that has nothing to do with the problem that came from the diagram. And that's possible as well too. But I just, had to have a place to start. So things that I might be able to state after this might be angle JKM equals 90 degrees. Ooh, Don't look at the answers to verify that I'm going the same order. Why can I jump to there? Why can I jump to angle JKM is equal to 90 degrees? Yeah. Definition of what? Perpendicular, right? I like that. Definition of perpendicular lines or something like that? What do you think? Can I say that? Yes,
So you wouldn't have to go to like JKM is a right angle first.
I think we could have said that. We might have been able to squeeze that right here. JKM is right. We could have, and I think that's an okay thought process too. And then that just means the next step would go to 90. But I think we're all on the same roll. Did I make too big of a leap going JKM equals 90? I don't think at this point, I think we're okay. Did they go JKM as right as the first thing in the...
Yeah.
Yeah.
They did?
And then when they said 90, the reason
Okay. Yeah, I could see that. Is that the way I would have necessarily gone? I don't know. Which is the right way? They're both right. Okay, but I like it. So JKM is definite, and they said this is definition of right or definition of perpendicular here.
It was okay, when they said it was right, it was definition of complementary, and then right angle.
Oh, I see. Okay. You know what? I like that too.
Oh wait, never mind. Perpendicular, not
Yeah.
complementary.
So the black would have been definition of perpendicular.
Yeah.
And then the next step was angle JKM equals 90 because definition of right. I like them both. I think they're both great paths. So let's stick with my green, not because this black's wrong, it's just let's stick with the green. From there, I could probably get away with this. Why? What? I heard it. Yes. Why is the substitution and not transitive in this case?
Is it the 90 that's the substitute?
Yeah, nice. That's it. So you knew this, and then you knew this. So I have a whole but I like substitution so much more in this case because this is two items I'm adding together to equal one item, and then I have one item equals one item. So I think the one item equals one item is the best way to go. I really like substitution here. Okay? If you threw transitive in there, it's kind of hard for me to say, nah, I don't think it's transitive. I think we could go with both. But I like substitution in this case just because this here, these two things are equal to this one. Now I'm saying that one here is equal to one thing here. So it's kind of a big jump. JKO is complementary to OKM. JKO is. Are we ready to prove it? I guess.
Can you say that definition of complementary angles?
For the proving?
Yeah.
That's what I was thinking. You know what I could do? Ooh. This might be better. This might be better. Let's go back a smidge. Remember last chapter? An angle's complement is, and we use 90 minus x. Remember this? Remember that? And a lot of you didn't like it, but what if I did this? What property just took place algebraically? Subtraction? Yep. Subtraction. Okay? Now you remember in the last unit, an angle and its complement. An angle was x, its complement was 90 minus x. You remember this? So now we want to say that angle JKO is complement to angle. JKO is complement. Well, I could have brought JKO. Yeah, we got it. It's there. Number 6. I like it. Oh my. Angle JKO is complementary to angle OKM. Number 6. Definition of complementary angles. That's it. Oh, that was cool. This is a great step right here. I like this step a lot because it really goes back to what the last chapter we did. An angle and its complement. An angle x, its complement, 90 minus x. An angle and its supplement, x, 180 minus x. I like that step right there. I like that a lot. Would I have gone right there with you guys at this point as far as proofs going? Probably not hardcore. I probably would go on that step, that yellow step right there. If you hit that step, I'd probably put a bonus point or two in there. Okay, that's a great step because that really shows you have the understanding of what a complementary angle is. An angle and its complement, it's right there. Oh, these are so cool. Oh, I love these. Thanks so much, guys and girls. You guys are wonderful. You let me teach this to you. I appreciate it. Like, you ain't teaching us nothing, man. We knew it. I know you did. I'm feeling pretty good. You guys? Anyone upset? Scared? Frightened? Nervous? Good. It's good for you. Okay. I think study tonight. What do you think?
Yes.
Oh, wait. Where did I just go? Midpoint of FG. Good. Can I get through this last one? I don't know. Can you, dude? Probably.
We're just waiting for you to write it down.
Oh, thanks. All right. Okay, I think I'm ready to rock and roll. Do I have time? I have time, I think. Okay.
5 minutes.
Okay, cool. I like it. First thing I think I would go to on this problem is I would take care of what step 1 states. If I'm going to take care of what step 1 states, what should I say? What should I say about this? Yes, thank you. Fn is equal to OH. At this point, I don't know if I need it, but this might lead us to a substitution or even a transitive property. Why can I say this? Definition of what? Definition of what? Definition of congruence. Good. So congruent, that means the same thing for the most part, but now I can start subbing it. Okay, cool. Okay, I like that. And you know what I'm going to do with that? No what? I'm going to say that Fn and OH are congruent, are equal. Is that okay? Okay. All right. I think we're okay so far. N is the midpoint of FG. So let's focus on this one right here. So what can I say? If N is the midpoint of FG, what can I say? Go ahead. Shout it.
NF is congruent to NG.
Not quite.
What do you mean?
I like what you're saying, but I think we need to step back for a smidge. And this is why. What do you think? What did you say? I want to do segment addition postulate. What am I going to say of that? Fn plus Ng Fg. I like it. Okay. I can also say this, that Jo plus OH equals JH. Okay. So those are just stating that I'm using the segment addition postulate. Segment addition postulate. Okay? And that's just saying, hey, I have this plus this equals the whole, and this plus this equals the whole. I like that. Okay? And I think, was it necessary? I don't know. It might have been. Things that I can now say from there. Oh, shoot. I could say all kinds of stuff. I can take this now, and I could do something here, or I could do something here. What do you think?
Wait, could you do FG minus Fn equals Ng?
Oh, wait. Wait. What'd you just say?
FG minus
FG minus Fn?
equals Ng.
Oh, you know, yeah. Wait. We're good. I like what you're saying. Okay, being that I'm trying to get to, let's see. Can I get Gn alone? I can get Gn alone. I can get that alone. Can I get OJ alone? I can get Joe alone. Okay, good. But we know this. All right.
2 minutes.
2 minutes. Oh man, I can get there. first thing, I'm going to say Fn equals Fg minus Ng. And then 8th step, I'm going to say that OH, quit with the bottles, please. Thank you. I know they keep falling on the floor. What did I do on both those steps? I did subtraction. So 7 and 8 were both subtraction. I like it. Oh, I can get there. I can get there. What can I?
2 seconds.
No way.
No.
Don't do that to me. What else can I say?
You got 2 minutes.
Okay. We're good.